Electronics and handheld industrial devices, secure communication equipment, portable instruments, and automotive infotainment systems are often powered from multiple DC sources such as main and backup batteries, wall adapters, and USB ports. Selecting the appropriate input supply to power the system is not a trivial task. I am Rajesh Venugopal, Senior Mixed Signal Design Engineer, and I'm going to introduce two products, the LTC4419 and LTC4420, that perform supply selection based on priority, or prioritization for short, in a seamless manner. These products are 18-volt, dual input, half-amp prioritizers with micro power operating current and integrated power switches. While easy to describe, supply prioritization poses several practical problems that are hard to handle through discrete implementations. Consider a discrete solution where an output is prioritized between a primary 7.4-volt 2-cell lithium-ion battery and a backup 9-volt alkaline battery. For this discussion, I will use primary to refer to the higher priority lithium-ion battery. Let's look at issues that arise as the output powers up and is switched between the two input supplies. A valid primary voltage turns on its power path, which results in a large inrush current to charge output capacitor Cout. Combined with the battery's equivalent series resistance, or ESR, this current causes V1 to drop below the switchover threshold. Now invalid, the primary path turns off, allowing the V1 voltage to recover. When V1 recovers enough to be valid again, the switch turns back on. This process repeats, resulting in a phenomena called motorboarding. Consider the scenario when switching from the higher 9-volt backup battery to the lower 7.4-volt battery. This will occur if the lithium-ion battery has been removed and is now being reinserted. When switch S2 opens, output capacitor Cout is charged to a value close to 9 volts. When switch S1 closes, a large reverse current flows into the 7.4-volt battery from the output capacitor. Large reverse current can permanently damage batteries and power path switches. This is referred to as backfeeding. Inrush current also causes large output transients, or DVDTs, that can feed through to downstream circuitry. Low voltage circuits may not be able to handle the fast edges or higher voltages and can be damaged. Controlled turn-on of the output is desirable to prevent this. In addition to these problems, any prioritization scheme must handle input sources with a wide range of input voltages. Let's look at how the LTC4419 makes prioritization easy. Both of the LTC4419 inputs, V1 and V2, can operate from 1.8 volts to 18 volts, accommodating a variety of power sources. Integrated 2-ohm power path switches permit prioritization without the need for external MOSFETs. A complete application requires only a single resistive divider. The LTC4419's fast current limit circuitry prevents large inrush current and associated voltage overshoot and ringing. Without this circuitry, the inrush current can be as high as the input voltage Vin divided by the power path resistance. The LTC4419's current limit ensures very little input supply droop, resulting in smooth power up and seamless switchover without motorboarding. Current limit also provides output slew rate control through the appropriate selection of output capacitor Cout, eliminating potentially damaging output transients discussed previously. When switching from higher to lower supply, in this case from the 9-volt backup to the 7.4-volt primary, the LTC4419 eliminates backfeed by activating its primary power path only after the output is dropped below 7.4 volts. The LTC4419 inputs tolerate negative voltages up to minus 15 volts, preventing damage from reverse polarity battery insertion. These features enable the LTC4419 to provide a high-performance, efficient, and compact prioritizer solution for a variety of applications. The LTC4420 provides all of the features provided by the LTC4419 with the additional feature of backup supply voltage monitoring to prevent deep discharge of rechargeable backup batteries. The backup supply is monitored by V2 UV at an interval controlled by V2 test, allowing for very low quiescent current. When the backup supply drops below a programmed threshold voltage, it can be optionally disconnected from the load by V2 disbar. In summary, the LTC4419 and LTC4420 are versatile, easy to use, dual input prioritizers that greatly simplify power supply selection. I hope they simplify your system design and that you will enjoy using them. For more information, please visit linear.com. Thanks for watching.